Hey there, welcome back to the channel. Today we're going to be working on our automotive controller. We're going to integrate an oil pressure sender. Let's get to it. This is just a generic 100 psi pressure sensor. This has got a Delphi GT150 connector on it. This one came with this, but in my mind this is pretty useless. This is about 8 inches, maybe 12 inches of cable. It's not going to reach anything, and so that means I'm just going to have to butt connect these to some other wires, which I don't like to do, so we'll probably end up creating a whole new cable. We'll get a new connector for it, but this is good enough for testing. If you recall earlier when I was talking about sensors, back when I was talking about temperature sensors, I said if it had 3 wires, it is probably a voltage, not a resistance. This one is 3 wires, and again, it is voltage. The way this one works is it takes in, this is the ground here, and it takes in 5 volts on this red, and then the output on this green will be between 0 and 4.5 volts, and it's a linear relationship with whatever the sensor is. So they make these in a variety of different ranges. This one is 100 psi max, so at 0 pressure you'll get 0 volts. At 100 psi you'd get 4.5. 50 psi you'd get 2.25. Now that's the theory of operation on these. In order to actually test it, make sure that my circuit for it works and everything, I really need some way to pressurize this. I'm not going to build anything that's hydraulic, but the nice thing is this is just looking at pressure, so we can do an air pressure as well. So we're going to create a little air pressure fixture that allows us to run up to 100 psi and be able to test the circuitry when we build this on our bench. We'll control the air pressure with this regulator here. What we'll do is we'll get a portable air tank, fill it up out in the garage, then we can bring it in and use this to regulate the pressure between 0 and 100, and then have the pressure coming in here, read out here, and verify that everything's working. So let's go build that fixture. I have the regulator set to about 90 pounds. There's a leak over at the connector down at the air tank, so it's bleeding off over there. If I wiggle the hose a little bit, it'll straighten up. We have this now set up to about 90 pounds maximum. This sensor goes up to 100, but oil pressure would never reach that. The bypass valve in the oil pump in the motor itself would prevent it from ever getting that high. So we're really good here. Now all we have to do is hook it up. So we've got ground and 5 volts coming in here, and then the output up to 4.5 volts. Nicely, our microcontroller has a 5 volt rail. We'll use that for testing. In the end product, we're not going to use the 5 volt rail coming off the microcontroller. We're going to have a higher amperage 5 volt rail that runs all of our peripherals, all of our sensors, and it needs to have some sort of protection against voltage spikes and transients and weird things like that. We're going to worry about all of that power conditioning later. Power supplies on automobiles are really, really challenging. You can see spikes up over 80 volts. It's really ugly. So we're going to worry about all that later. Right now, we'll just give it 5 volts off the rail, read it back, make sure that we've got it scaled. It looks right compared to what we're setting on our regulator, and then build some code that abstracts it into an oil pressure gauge. If you recall, this sensor puts out from 0 to 4.5 volts, so I've got 4.5 here. The input on our microcontroller is a 0 to 3.3 volt range. It's tolerant up to 5 volts, so if we gave it 4.5, it wouldn't break anything, but anything above 3.3, it just reads as 3.3. So we have to bring our voltage down to below 3.3 at maximum in order to get resolution to be able to read it. You can see right now it's at 3.0, which is really good. I mean, that's right at what we would want. This circuit is a little bit more complex than the ones we've seen in the past, in that I've got this Zener diode right here. Now the purpose of this is that if we have this all hooked up, and let's say this is a screw terminal connector on our board, if the installer or user accidentally plugs 12 volts into this, well, let's see what would happen if we put in 12 volts. So if the user plugs in 12 volts here, this Zener diode's going to bypass all of this, and we're only going to get up to about 3.5. So that's going to protect our microcontroller. All of the other circuits I'm going to do similar stuff on, and when we get to that point when we're actually doing the PCB layout, you'll see all of those. For the breadboard, I probably won't even bother putting this on, but I will put in all of these resistors. Let's go breadboard this, hook it up, and write some code. This is really similar to what we had done for the temperature sensor. We've just built a voltage divider over here. So we've got the 5 volts here, the red, which is fed from over here, and that feeds into the sensor. And then this is the ground from the sensor that comes back to ground. And then the sensor's output here is 4.5 volts, goes through this 100, and then this 2.2K, and then this is our midpoint of our divider, and then this is the 4.7 back to ground. This comes back into our analog A2 on our Meadow. Let's go look at the code for this. To test this, I've just created a real simple app. Basically, we're going to create an analog input port, just like we've done before, on A02. This is our maximum voltage that we expect at the voltage divider. It equates to this pressure. So we read the voltage and do a conversion of that voltage to our recorded pressure, and then does that every 5 seconds. Let's push this to the device and see how it looks. The first thing I notice is I have 0.35, 0.33. We've got about 1/3 of a volt with no pressure at all. So that's telling us that we have 10 psi based on our calculation. So our assumption that this sensor goes from 0 to 4.5 volts is incorrect. So let's go adjust the code for that. Alright, let's try it again. Alright, now we're seeing a lot more like what we would expect. 0.74, 0.32, so pretty much 0 psi. And we're getting down up around 1, but the reality is we're never going to have exactly 0. This is close enough for our low end. Now let's check the high end. Our tank has about 90 psi in it, and we've got the regulator set for 90, so let's send air over to the device. Well, that's wrong. With 85 pounds of pressure on the regulator, and that regulator matches the gauge down on the air tank, our calculation is still only showing about 75, so we're not getting as much voltage out as I would expect. The question that I have is this 5-volt rail coming from this device actually 5 volts? If that's not the case, that will definitely throw our calculation off. So we connect up here and here, and that explains it. It's supposed to be 5-volt reference, and we're only getting about 4.4. So it feels like the Meadow might not be sourcing the proper voltage for this sensor, which is throwing off our calculation. When we actually build this, we're going to have a dedicated 5-volt power supply. It won't be coming from the Meadow, so we shouldn't have that problem. But to verify that this is all working, we'll use the bench power supply and give it 5 volts instead of coming off of the Meadow, and we'll see how that affects our results. Alright, now we're giving it 5 volts of power. The meter confirms that. Let's give it some air and check the values again. Now that we have an actual 5 volts going in, first thing I notice is our floor has gone down. So at atmospheric, it seems to be hovering around here. So let's change this to 0.15. And then let's try this again. Alright, now our 0 atmospheric pressure is about what we expect. -1 to 1.5. So it's floating around a little bit, that's fine. But let's run it up to pressure and see what happens. We have about 80 pounds of pressure available still in the tank. And it ramped up to, looks like 77, 76, so that's really close. It looks like when we have the correct voltage for a source, we're getting values that we like. It turns out that when you have the correct source voltage, the sensor works like it's supposed to. It still isn't going all the way down to 0 volts, but that's not a problem. We've got our circuit designed here. We have code for it. This is ready to go. That's all there is to it. Thanks for watching.